lesson, we are going to find the number of factors of any given number. Let's start with a simple example, say 24. We want factors. Now, factors are less than the numbers, right? Factors are numbers that can divide the given number. So, 1 is a factor of every natural number. Is 24 divisible by 2? Yes. By 3? Yes. By 4? Yes. Before you get an idea that they are sequential, is 25 divided by 5? No. So, 5 is not a factor. 6, it is divisible. By 7, no. By 8, yes. 9, it's not divisible. 10, 11, 12, it is divisible. 12 is half of 24. After doing the complete theory, you'll understand that the next factor will only be 24. You can check for yourself. 13, 14, 15, 16, 17, 18. None of them is going to divide this. So the factors are 1, 2, 3, 4, 6, 8, 12, 14. We want the number of factors. So we are going to count them up. And when you count them up, we say there are 8 factors. So how do we come to this number? 8 is our agenda. So in a general case, we could say if I have a number n, when we talk about factors, I'd again always ask you to think in terms of left factor small. 1 is a factor of every number and the largest factor of n will be the number itself. So what I just want to tell you here is the number of factors are going to be limited in quantity, right, from 1 to n. So we should be able to find how many of them. How do we do that? It's a pretty easy one. You need to be able to divide 24. So look at 24 in the factorized form, that is 8 into 3. Now, I want a number which can divide this. So, a 2 raised to 0 can divide it, 2 raised to 1 also can divide it, 2 square can divide it, 2 cube can divide it, 2 raised to 4 cannot divide it, 2 raised to 5 cannot divide it, anything further cannot be divided. Similarly, if I look at powers of 3, 3 raised to 1 is what we have in the number. 3 raised to 0 is a natural number 1 which can divide the given number. 3 raised to 1 also can cancel out the 3 raised to 1, but 2 cannot 3 square cannot cancel out the 3, 3 cube cannot cancel out, anything further cannot be cancelled. So what we are left with is, when we look at these numbers, these are your factors. These are your factors. These factors could be anywhere from, the power of 2 could be 0 to 3. 0, 1, 2, 3. And the power of 3 could be from 0 to 1. Right? 3 raised to 1, so 0 to 1. 0 to 3 are 4 different possibilities. Are 4 different possibilities or 4 different values you can get. 0 to 1 are 2 different values. 0 and 1 are 2 different values that we have, right? And we need a combination. So the factor is going to be any power of 2 with this limitation, any power of 3 with this limitation, and the two have to be multiplied together. Since we multiply together, if you're okay with PNC logic, an event can happen in 4 different ways, an event can happen in 2 different ways. In how many ways can both the event A and B happen is m into n. So I would be getting 4 into 2, that is 8 different values. 8 different values for the factors. Right? Let me specify these. What are these 8 different values very quickly, right? So I could have a 2 raised to 0 or 2 raised to 1 or 2 square or 2 cube. These are the 4 different values. With each of them, I could have a 3 raised to 0 or a 3 raised to 1. 3 raised to 0 or a 3 raised to 1, and that is happening with each of them. What I want to do here is to try to tell you what we have enumerated, the different factors. I am working them out here. So what is that first? 2 raised to 0 into 3 raised to 0 is 1. 2 raised to 0 into 3 raised to 1 is 3. So you have counted this 1, you have counted this 3. 2 raised to 1 into 3, 0. That is a 2. 6. 2 into 3, 6, you have counted. 2 square into 3 raised to 0 will be a 4. 4 into 3, that is a 12. 2 cube into 3 raised to 0, that is an 8. And this is your 24. So all these 8 values you have got them here, right? That is how you get your 8 values, the 8 factors. So just pay attention a little to this. You should be, rather than me, I'll give you the formula sort of thing, but then you should be able to derive the formula in your own ways, right? So how does the formula look? What did we do to 24 first? We took it in the factorized form. So this number n, we can write it in the factorized form. This also tells you should ideally have seen the lesson on factorized forms before doing this. And if we have this for any factor of the number, the only possibilities are the power of 2 could be 0 to a. Only then it is going to cancel out with a 2 raised to a. The powers of 3 should be 0 to b. And the powers of 5 has to be 0 to c. And 0 to a, mind you, is nothing but a plus 1 values, possibilities. Let me write it here, possibilities. There are a plus 1 different possibilities. Similarly, 0 to b is b plus 1 possibilities. 0 to c is c plus 1 possibilities. And so on. There could be more numbers also, right? Depending upon how many prime factors the original number had. So the total possible values for the factors is a plus 1 into b plus 1 into c plus 1 and so on. These many different possible factors. This is that so-called your formula. Let's denote number of factors using this notation, number of factors of n. So this formula is peddled across a lot. We don't prefer just giving formulas. You should have a clear idea of where does this plus 1 come from, because you're taking from 0 to that value out over there, right? So let's just check as an example. Let's find this very quickly. I want to find the number of factors of the number 36. So take 36 in the factorized form, divisible by 2 by 4, 4 nines are. 4 and 9 are made from different primes. So 2 square into 3 square. And what is the number of factors of 36? This is how we'll denote it in shorthand. Is going to be, take this 2 plus 1. Take this 2, this also 2 plus 1. And there are no further primes. So this is 2, 3, 3 3s are 9. Remember, it doesn't matter, had there been a 5 raised to 0, and that 0 would have been nothing but 0 plus 1. And so if you multiply anything by 1, the answer still remains the same. So it doesn't matter whether the primes which are absent, you can use them even in the formula, right? It will just keep adding multiplicants of 1 into 1 into 1 into 1 into 1 as many. The answer wouldn't change. Let's check it up. 1 is a factor, 2, 3 can divide it, 4 can divide, 5 cannot, 6, 7 no, 8 no, 9 yes, 10, 11, 12 yes, 13, 14, 15, 16, 17, 18. The moment you reach a half, you know the next will be the number itself. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the correct answer. Hope you have learned the process, right? Now, why we don't prefer the formula is, it's very rarely you're going to get a question straightforward, find the number of factors of 36. I might add a lot of conditionalities to which factors you're searching. I don't want all the factors. I want factors that specify a specific condition. And when such things come, then the formula is useless. Then what helps us? This process of how do we find factors. So let's take a look at questions with such specific conditions on the factors.